start our last lab tour. It's the Biometric Systems Robotics Lab with the PI Jorge Lozoya Santos, and I believe his students are also speaking.
Yes.
Hi, everyone. Thank you. I have a question. How I can get a t-shirt from Brain? Like
Question.
Yeah. Nice. Thank you. We are very happy to be here. In our lab, we are doing a lot of interesting things, and our lab virtual tour will be presented by our program manager, Mauricio Ramirez.
Yes. Hello. Thank you.
Thank you, Mauricio.
Let me see if I'm sharing the sound. So just tell me if the sound is fine.
Yes, yeah. Sound and yes, thank you.
Okay, thank you. Well, last time we presented some 3D virtual tours of the labs, but now, well, we haven't got access to the campus like in a year, so we explore different ways to perform experiments. So that's what we are presenting today. These are some of the equipment that we have. We have EEG devices, we have dry electrodes and gel electrodes. We also make use of wearable devices, such as smart wristbands to measure and monitor EDA, heart rate, temperature, and acceleration. We also make use of artificial vision devices, such as depth cameras. And we also are developing a customizable robotic platform, which is called Pivot. This is one experiment. One of the students made this video for us, and this shows one application, one neurotechnology application oriented to education.
Hello, my name is Rafael Abreu.
My name is Gabriela Alvarez.
And we're both students at Tecnológico Monterrey participating at the BRAIN International Initiative. So what we will be demonstrating today is an experiment we've been working on the entirety of the semester of 2021. It's the ALICE experiment, and it consists of an electroencephalograph, a Raspberry Pi, which is linked to the electroencephalograph in a microelectronica hexagon. The electroencephalograph is linked to a Cyton board, which is linked to the Raspberry Pi. The Raspberry Pi has a machine learning algorithm incorporated, which allows it to connect with the devices and incorporate all of the information recorded from them. From the electroencephalograph will be the brain waves, obviously, and from the hexagon it will be the heart rate and the user's temperature. We're utilizing this data to incorporate it into machine learning algorithm, as already previously stated. Said algorithm will be analyzing the user's fatigue levels as they're doing certain activities. In our specific case, we'll be utilizing applied learning activities, and we'll analyze how the user's fatigue changes over time as they're learning. So now we'll demonstrate how this setup works. Everything is made utilizing Python and Google Initiative.
PIMOS is a communication protocol between electronic models which allows to transport large amounts of data through a single cable. Its components are the controller, which receives, encodes, and sends information, multiplex cables, which filter electrical noise, and the terminator, which is used to close and adjust the system's operation.
Okay, now I will show this other video, which is a talent detection system oriented for children, which other students are working on this project.
Hello, this is the data acquisition virtual tour for the project BRAIN, which is carried out in conjunction with Machine Care Education and Tecnológico de Monterrey, Campus Monterrey. The team is made up of 6 members. Firstly, Miriam Alanis, PhD, is our lead researcher. Luis is focused in the biomedical engineering area. Juan Carlos Ocampo is focused in clinical psychology. Gladys is focused in biomedical engineering. Gustavo in mechatronics engineering. And myself, Diego Botín, is working currently as project manager.
So the way we did the experiment is at first whenever the kid comes to the engineering courses, we place the equipment, which will be explained after this. Then we connect everything to the computer, and for the EEG equipment, we check the impedances to make sure that the signal we will acquire will be correct. Then the kid has to answer a small questionnaire so we can know how his mood is that day, how he's feeling, and if he feels enthusiastic about the class. And lastly, we begin the signal acquisition. We take 1 minute of eyes closed and 1 minute of eyes open to have like this baseline on how the signals are. And then we cover the 2-hour sessions, which we divide into blocks of 1 hour to analyze the signals afterhand.
This is the screen we normally see at a session. In the left side, we have the data given by the Empatica and the video of the kid. And in the right side, we have the 8 EEG channels. Visualizing the data is useful to see that everything is running smoothly in the experiment. Devices are wireless. This gives the kid the liberty to take their class without any interruptions.
So then we have the equipment. What we use to take these signals are the SmartBand Empatica E4. Then we have the Brain Products electroencephalographic cap. And finally, we have a camera, which is actually a stereo camera, which is this model from Intel. It's the D435i. And this is the equipment we managed to acquire these signals.
So the signals acquired with this equipment are basically the EEG 8 channels for this particular configuration, the heart rate variability, the blood pressure volume, the temperature at the wrist, the EDA or GSR galvanic skin response, accelerometer in the wrist for filtering of signals, and facial expressions.
Now, what is our goal? First, to have a precise, accurate, and objective measurement of interest in STEM-related activities. Then, to design tools to evaluate projects and initiatives that aim to promote interest in STEM fields in children, both public and private. And lastly, to propose an innovative method to measure professional interest in children besides psychometric evaluation and psychological interview.
Hello.
Thank you. That was a video for this project. Now, moving on, this project is the Pivot, the robotic platform that is oriented to interaction with humans, and it can also perform people detection, people counting, autonomous navigation, and thermography. Here's a video that one of our students made for us as well. This doesn't have any sound, so I can talk as the video goes. This was a test that was carried out actually in campus, and the student was controlling the robot here, and it was performing people detection and people counting here. We will see some examples. It detects some persons around campus. It also shows if the people if they are too close. It could be dangerous, right, for contagious. This platform has a web application, so another person can be monitoring what's happening, what the robot is observing and detecting in real time, and they can also control it. Here, one of the students is showing the robot in another site from campus, and he can control the robot, the direction, the movements of the robot. And this is a simulation on some autonomous navigation routines that the robot has. Finally, this shows how a user can interact with the robot with the use of some smart glasses, and what kind of alerts or messages the user can see from the robot. Just how many people are in some rooms, if there are some alerts or danger. This is one comic that one of our students made for us. She's called Linda. She's the artist, and we are currently on some last details on this comic. We can share it with you when it's done. Well, I'm going to paste these links. These show some 3D tours. I don't think there's more time, so I'll just paste them and you can explore them whenever you want. And well, here's our team made of faculty members, or some graduate students, a lot of undergraduate students, and our industrial members as well. So well, that will be for our tour. Thank you. If there are any questions, feel free.
Thank you, Mauricio. Does anybody have any questions for the site at Tech Monterey and their presentation?
You may have mentioned it, but what machine learning algorithm or algorithms were you using in the ALAS project to analyze the multimodal data?
We are currently using, well, we explored first machine multilinear regression algorithms, but then another student is using SVMs, random forests as well.
Thank you.
I think random forest was the latest choice. Yes.
All right, any other questions? Well, that was our last lab tour, but does anybody have